Once upon a time, there was a fat rat. We'll call him Chunk. Chunk got his name because he became quite proficient at eating bait from mousetraps without ever setting the traps. His success continued for quite some time until he came across a mousetrap that was designed by a Science Fun YouTube subscriber. As he approached, he laughed because this mousetrap didn't even have a trigger. This will be easy, he thought. But as his little snout broke the laser beam, he was met with certain death. Welcome back to lesson 2 of our ultimate guide to Arduino automation. In this episode, we will be combining what we've learned about digital inputs and outputs, and I will show you how to use them together to make cool things like that ridiculously over-engineered laser-activated mousetrap.
In the introductory video, we talked a lot about digital inputs, and really there are quite a few different types of devices that can be used as digital inputs to the Arduino. Here are just a few of my favorites. This one is a magnet detector. So this would be similar to your burglar alarms on your houses, on your windows and doors. This one is a proximity sensor, and it's used to detect when something passes over it. This one is activated when it tilts up. The little ball inside rolls and makes contact. This one senses shaking or vibration. And of course we have traditional buttons and switches, and also our laser sensor.
Now we know that the Arduino digital input pins are looking for either a high or a low voltage, but if we don't set our pins up correctly, the voltage can actually float up and down and give us a bunch of false readings. We want to avoid that, of course. And so here are a few ways to set up your digital input pins properly. First method is what we call a pull-down resistor, where we put, say, a 10 kilo ohm resistor in between our digital pin and ground so that it defaults to a state of low. We then connect our digital input device. In this case, we're using a button. We connect that between our digital input pin and the 5-volt pin on the Arduino. That way, when we push the button, it will switch from low to high. Similarly, we have the pull-up resistor method, in which the button and resistor trade places, so that the pin normally reads high, but when you push the button, it will switch to low. Now, the good thing about the Arduino Uno is that it has built-in pull-up resistors that you can access in the software or in the sketch. And this really simplifies the wiring because the pins default to a high state, but if we connect our digital input device in between our digital pin and ground, we can have it toggle to low when we push those buttons.
Well, let's talk about this mousetrap, and then I will show you how easy it is to write the sketch that goes along with it. First off, we have our laser, and that is simply powered with 5 volts. So black goes to ground on the Arduino, red goes to the 5-volt pin, and that powers our laser. Opposite that, we have our laser sensor here, and this has 3 wires, one ground, one 5 volts, and then the middle pin connects to Arduino pin 2. Over here we have our solenoid, which releases the latch on the mousetrap, and it is powered with an external power adapter. I've used a 24 volt for this example, and it is triggered using this relay that we talked about in our last lesson. So if you missed lesson 1, you might want to circle back to see how to connect these to the Arduino, but it is pretty simple. There's a power pin, 5 volts, ground, and then our digital output is this yellow wire here connected to pin 3 on the Arduino. All right, so let me turn this on just really quick using my 9-volt battery, which will power up the laser. And then what happens here is when Chuck comes across this laser beam and interrupts it, the relay will turn on. All right, so let's go write the code.
So go ahead and open up a new sketch if you'd like to follow along. First thing we're going to do is we're going to throw in a couple variables. We will have an integer called sensor, and we will set that equal to 2, meaning pin 2 on our Arduino. We will have another one called trigger, and we will set that to 3. Don't forget the semicolons. And we'll have a Boolean, which is a true false. We're going to ask if the mouse is alive. And we're going to set that initially to be true. Start off with him very much alive. Now here in the setup loop, we're going to write pin mode, capital M. We're going to start with our sensor pin, and we're going to call that an input. We will use pin mode for the trigger as well, and we will call that an output. And then we will set our trigger initially to be off or low. Because we don't want to spring the trap too early. And then we're going to wait 1 second just to allow everything to stabilize before we move into our loop. Okay, so down here in the main loop, we're going to start off with a question. If the mouse alive is equal to, notice the double equal signs, if that is true, then we are going to do the following, and you use these curly brackets. We're going to ask another question. If the digital read of our sensor, if that is equal to high, meaning the mouse has sprung the trap or interrupted our laser, we're going to do what's in these curly brackets. We're going to do digital write to the trigger, which controls the solenoid, the relay for the solenoid. We're going to set that high. And then we're going to wait 1 full second for the solenoid to energize and do its thing. And then we're going to immediately turn it back off. Okay, and then once we do that, we know that our mouse alive is actually not true anymore, but false. We have killed the mouse. Okay, so let's check our code using our verify button here. See if we have any errors. Looks like we're good, so we can go ahead and upload our sketch. If you enjoyed this lesson, be sure to zap that subscribe button, and we'll see you back in lesson 3, where we switch from digital to analog.